The next section, 4.3, is on the free radical chain reaction. And this reaction, the free radical chain reaction, was the mechanism that was ultimately proposed to explain the chlorination of methane, to explain the three observations that were made by the chemists who were studying the reaction originally, and to help us understand the mechanism and answer the questions about the reaction. Chain reactions, all of them, not just the chlorination of methane, but all chain reactions have 3 steps to them. The first step in a chain reaction is called initiation. The initiation step generates from a stable molecule, it generates a free radical. A free radical, I can't remember if we talk about these in Gen Chem or not. We probably do. A free radical is defined as an atom or a molecule, or it could be an ion, that has at least one unpaired electron. Unpaired electrons, not really a concept that we spend a lot of time on in Gen Chem. So that probably to you seems not very stable, highly reactive, not a preferred arrangement for an atom, and for the most part, that's correct. It's not really how they like to exist. So going back to the chlorination reaction, one of the things that the scientists observed is that the reaction yield was higher when the light was focused on the chlorine molecules in particular. That led them to figure out that the reaction, the whole entire chlorination reaction, was initiated by the light molecules interacting with, the light interacting with the chlorine molecules. When the light interacts with the chlorine molecule, it actually splits the chlorine-chlorine bond, and it splits it in a way where the 2 electrons in the bond get divided up between the 2 atoms in the molecule. One of the electrons goes to one of the chlorine atoms, the other electron goes to the other. You'll see that I'm drawing these arrows that they have only half of an arrowhead on them. When you learned resonance in Chapter 2, you learned to show the movement of electrons using a curved arrow with an arrowhead. The curved arrow with a regular arrowhead shows the movement of a pair of electrons. A curved arrow with a half of an arrowhead shows the movement of a single electron. And so this reaction produces 2 chlorine radicals, and they're both very reactive. The second step in a chain reaction is called the propagation step. In the propagation step, free radicals that are generated in initiation will react with a stable molecule, not another radical, and they will produce more radicals, different radicals. Propagation is the free radicals reacting with stable molecule to make new radicals. Now in this reaction, in this chlorination reaction, our chlorine radical in one of the propagation steps reacts with a molecule of methane, which is very stable. And in this reaction, And you got to pay close attention here. One of the carbon-hydrogen bonds will break. And it will break in the same way that the chlorine-chlorine bond broke, with the electrons splitting apart. One of the electrons in the carbon-hydrogen bond is going to go on to the carbon atom. So one's going back to the carbon. The other electron in the carbon-hydrogen bond is going to come out here and hook up with that unpaired electron on the chlorine atom. Those two atoms together are going to form a hydrogen-chlorine bond. So this bond right here came from the combination of this electron, this unpaired electron on the chlorine, and one of the electrons from the carbon-hydrogen bond. The other electron from the carbon-hydrogen bond stays on the carbon atom, and it generates this radical, a methyl radical.